Hi all, welcome back to the channel. This week's video is going to be on the new trim range feature. This pairs really well with dynamic array formulas. Let's have a look at what the trim range function is. Trim range is a new function that returns the used portion of a range, meaning it trims off any empty columns or rows from your data, leaving just the used data inside. If you're still using named dynamic ranges with functions such as offset, index, or counta, then you no longer need to use these. The new trim range function does it all simpler and more efficiently. Let's take a look at how we use the trim range function. To illustrate a range inefficiency without using the trim range, we're going to select this data set, and to allow for growth, we're going to go all the way to the bottom of the sheet, down to row 1 million. Now if I press enter on that, our spill array will spill all the way down to the last row of the spreadsheet, and you can see we've got a load of zeros in our blank array, and it's highlighted with our blue outline. Now to avoid this problem, we can wrap this within trim range. So I'm just going to start typing trim, use the arrow keys down to trim range, press the tab key, that's our range set. And now there's two arguments. We can tell it the number of rows we want to trim, and also the number of columns we want to trim. For this example, we're just going to trim off any blank rows from the end of our array. To do that, we can use the trailing argument. You can also do leading, so empty rows from the start of your array. You can do none by using 0, or 3 for both the leading and the trailing. I'm just going to press the tab key to confirm 2. And then our columns, I don't want to allow for any growth in this data set. It's always going to be these number of columns. So I'm just going to press 0. I'm going to close the argument. Now we're left with a dynamic array that's spilling just down to row 11, which is where our data set ends. This is far more efficient for Excel to calculate now. There's only a small number of rows versus the million that we had in the previous array. Just to test that this is a dynamic array that is going to grow and shrink with our data, I'm going to add a test row. So if I put in Ben Jones, you can see now the array has grown by an additional row, and we can test another one and another one. So that seems to be working perfectly. You're probably thinking that the trim range function is quite long. Now when you start mixing this into dynamic array formulas, wrapping all your arrays within the trim range wording is going to make your formulas a lot longer. There's a way to avoid this. To avoid using the trim range function in its long form like this, we can use the dot operator, which is the shorthand method for declaring a trim range. Instead of this example where we've wrapped trim range around our array, we're going to get rid of that, and we can now use a dot before our colon. That's going to trim leading columns and rows. We can put a dot after our colon. This is going to trim trailing columns or rows. Or we can put a dot before and after our colon. This is going to trim both leading and trailing rows. So if we press enter now, you can see we end up with the same dynamic array that we just achieved with that longer trim range function displaying. We're going to have a look now at a formula that uses an entire column reference as its base data, and we're going to compare how slow that is versus using a dynamic trimmed range using the trim range dot operator. In this example, I've used a sum product which is going to tally up the total goals scored by anybody in the current position. So for this particular row, we're going to total all the goals for all the midfielders. Now you can see here, we're operating this across the entirety of column E and the entirety of column C. So there's a huge array that Excel's going to try and calculate now. Now if I press enter, this isn't too bad for one particular cell, but if we copy this and go down to the bottom of our 800 row example, and paste this in, you can see the calculation is now running, and this could take, by the looks of it, around 30 seconds to calculate. So now that that's calculated and given us the total goals per position, let's have a look at how we could improve this using the trim range. So where we have column E, that some people might use to allow for growth in their data, not realizing they can specifically reference a number of rows with data in, we're going to add in from E4 down to E1 million. Now that we have that range, we're going to add a dot to trim all the trailing blanks within column E. We're going to do the same for column C, so from row 4 down to row 1 million. And again, we're going to trim the trailing by entering a dot there. Now if we commit that formula, let's have a look how long this takes to calculate versus that last example using an entire column. So that was pretty instant. So if we copy that formula, Shift Control down, Control V to paste, and there's the result. Took about a second to calculate that versus the maybe 30 seconds of the previous example. So there's no reason to be referencing entire columns within your formulas now. You can allow for growth and to specifically target only non-empty rows using the trim range function. Even if you used to use the old named range trick with index or offset to achieve this, then you should consider switching over to using the trim range shorthand operator. Not only is it faster, it's more efficient. Let's take a look at some of those old methods. So in order for this to be a named range, we would have traditionally gone to the name manager, which is in formulas, name manager, or control and F3. And then we would have begun by typing our named range. So we could have called this data, then we could have used the offset function to go from our first cell, offset by no rows, no columns, and then our size of our data to be a counter. So this is going to count the number of blank rows from cell A4 all the way down to A1 million. We'll close our counter on our rows, and then for our columns, in this simple example, we could have typed in 5. Close brackets on that, click OK. Now if we were to click into this, you can see it's now found our array by using the offset function. The trouble with the offset function is it's a volatile function, and by volatile what I mean is every time you change a cell within any of your workbook, it's going to force a recalculation of that function. This means that you're going to create a bottleneck of recalculations for every single named range where you've used the offset function. An alternative approach would have been to use the name manager, so Control and F3 again, and we could have done data 2. We could have used the index function, so we could have gone from this cell and then colon index, and then we'd index this array, and the number of rows we'd want from that would be a count A from A4 all the way down to A1 million again, and then the columns argument within the index could be 5. Close brackets on the index and click OK. Now if we do the same, if we click on this to see if it's recognized our range, and it's correctly recognized that range of data. Now if we compare that to our new method of using the trim range, we simply go from A4 across to E4 using the shift key and arrows, then Control Shift down twice. If we add our dot operator into here, and if we test this like the others, look into here, you can see we've correctly identified the right range now from those millions of rows, using nothing more than adding a single dot to our standard range. No more index counter, no more offset counter, no more volatile functions. Nice, clean, simple formulas. So those table lovers might be screaming at the video right now, asking why are you not putting these formulas within tables? The tables will automatically calculate the column. The formula will therefore grow with the column as it expands or contracts. The trouble is new dynamic arrays, the way of writing formulas, are not capable of spilling within tables. So this trim range function works perfectly with these examples and also other examples where you're not using tables. So there we have it. Trim range is cleaner than offset, safer than index, and faster than both. So if you're still relying on full column referencing or complex counter formulas, now's the time to switch. Remember to hit that like and subscribe button to support the channel, and let me know in the comments your favourite use cases of the trim range operator. Thanks for watching. See you again next week.